Okay, so you guys have your scores. You've had a chance to look at them. Listen, please. Okay. If you don't do anything, you can expect to get a similar result on tomorrow's test. Okay? I would really strongly encourage you now to pay attention as we go through these questions. I'm also going to be recording this, so you can feel free to listen to it tonight, some too if you need to, if you kind of forget, like, ooh, I need to hear that one explanation again or something like that. Okay? All right? I really feel like this test is very doable, but I know it's got some difficult stuff on it too. Okay? Olivia, do you have a question? No, okay. So we're going to go through this here, question by question. All right? And hopefully, we can get to see some better scores on tomorrow's test than what we saw on Friday. Okay? So here we go. And again, at any moment, if you need to, raise your hand, and I'll, answer any questions. And of course, I'll be asking you guys questions too. So please be following along as we do this. All right? All right. So, all right, here we go. So number one, right, very important we read through the directions here because some people misread the directions on number one, okay? So the graph of f of x equals the square root of x is shown with point D plotted on the graph. So there's the square root of x, right? Very familiar graph to us now, hopefully. There's point D plotted, okay? The graph f of x is translated to form the new function of g of x. So we're going to translate, shift it to form g of x. Here is what g of x is the function would look like. Okay, it's f, but it's got the x plus 3, okay, and it's got the minus 2 on the outside. So g, how is g shifted from f? What do we do to f to get g?
Right 3.
No. Not right 3. What is it? Left 3. Okay, and I understand, Grayson, but we need to know this, right? That plus 3, we say this over and over again, right? The number that's in with the x, you do the opposite of what you'd expect. So left 3, the minus 2 on the outside, down 2. So how do you move the starting point for this equation? We're going to go 3 spaces to the left, and we're going to go 2 units down. Okay? That's the transformation there. Now we'll talk about point D. If you moved point D in the same way, where would it end up? Okay, draw this on the graph above. So D, if we're going to move it in the same way, how should I count? I should go left 3, down 2, and then that's the point right there at 1, 0. I'm going to label it as D with an apostrophe, D prime. That's how you label transformed functions there. Okay? What are the new coordinates of point D for the function g of x? Well, what's the coordinate for point D right here? It's got a coordinate 1, 0. Okay, 1, 0 is a new coordinate for point D there. Cameron, can you get your head up there, bud? I know if you're tired, but look, you gotta be paying attention here. Okay?
I just need a copy of this.
Oh, gotcha. I think it's right there on the top shelf, upper left there. Okay? So let's take a look at the next one here. Number 2, the step function f of x equals x there is graph to the right. Okay, so there's the step function. Explain why 4, 3 does not belong to the function f of x. Okay, so let's locate that point, 4, 3, and see what's happening here. So 4, 3, right here, right, because there's 2, there's 4, so the halfway is going to be 3. I'll zoom in on this one. There we go. Why does the point 4, 3 not belong to the graph? Jackson. Open circle, that's right. Okay, there's an open circle at the point 4, 3. Does anyone have a different explanation that they wanted to say? Okay, that's fine. Okay, yeah, 4, 3 does not count. Okay, all right, let's take a look here. Graphing piecewise functions. Okay, and then it also says to evaluate the function for the given domain values. Okay, so question?
You start at 1.
Okay, right. So there's a couple ways you can graph these piecewise functions. Okay, one way, the way we kind of been doing it, is I have you graph the entire line. Okay, so yeah, Trey wants us to start here with, we're going to graph this top function first, the negative 2x plus 1. So yeah, start at 1 there, Trey, you're right. And then what? Down to right 1, down to right 1, down to right 1, down to right 1. And also I can go up to left 1, up to left 1, up to left 1, and then I'm kind of out of space.
And don't you erase the stuff that's less than 2?
Right, so at this point, I'm going to look over here and see, ooh, wait a minute, though. I only want to graph parts that are less than or equal to 2. So I need to look here. here's my x value of 2, and there's a point. There's my point where x is 2. And I'm going to graph less than or equal to 2. Should I graph to the left or to the right for x values less than or equal to 2? To the left. And so we're going to look something like this. Okay, just connect the dots there, this direction. Okay, nice and dark if you like. Okay, and then I'm going to erase these other points here because they're not to the left of 2. And I'm going to put a solid dot here as well because it's got the equal to. Okay? So, there's that first piece. Questions on any of that? You may, Chloe, yes. Come back, though. Hurry back. We're going to be learning new stuff. Or we're not learning new stuff, but reviewing here. You're missing out. All right, next one. We're going to graph 5x minus 4. So down 1, 2, 3, 4. Put a point. And then up 5. Right 1. Up 5. Right 1. Up 5. I'm out of space. And I can't go down 5 at all. Okay? Now here I want to graph for x values greater than 2. So again, I'm going to locate that x value greater than 2. Here's 2. Okay, there's my point. Okay? Since it's greater than and not an equal to, what kind of point should I put here? Open circle or filled in circle? Open. So open circle, and I'm going to graph to the right, so I'm just going to go kind of like this direction here. I don't really have any other points to aim towards, but that's the basic idea there, and then erase these other points. Okay? So there's your final answer right there. Maybe I'll put that in red. Bless you now. Bless you. Okay? Questions on any of this? Okay, just like that. All right? No questions there?
Well,
Question here?
can do it on the calculator.
Yeah, it's hard to graph on your calculator. I mean, there are ways to do it on your calculator, but you have to be able to then erase the parts, Eric, that, you know, with the x values here, with the limiting x values there.
I see.
Okay, so you would use these to help you then erase the pieces, you know, to keep the pieces that you're supposed to, right? This tells you what pieces to keep. So you can graph this whole line on your graphing calculator, but then you only want to keep the parts where x values are less than or equal to 2. And only graph those pieces, like this piece right here. And same thing here. For x values greater than 2, you only want to graph the values that are greater than 2.
Okay.
All right, number 4. Okay, this also, Eric, you can use your graphing calculator. So actually, I'm going to use our graphing calculator here to graph the x squared minus 1. So, let me clear everything out here. Okay, so x squared minus 1. There I'm typing in my graphing calculator. I'm going to go to graph. Okay, there's the graph. But I'm actually going to go to the table here and use some of these points. Ooh, these points are way out of the whack. Okay. So let's see here. I've got some nice points like negative 3, 8, negative 2, 3, negative 1, 0. So I'll plot those points. So negative 3, 8. Okay, right there. And then negative 2, 3. Okay. 0, negative 1. Negative 1, 0, 1, 0. And we can just use symmetry then to get the rest there. Okay, so there's my parabola. Okay. Again, it's negative 3, 8, negative 2, 3, negative 1, 0, 0, negative 1, 1, 0, 2, 3, 3, 8.
You go with your calculator
Yep.
or the equation that you put in to get the points.
I just typed in x squared minus 1, what I saw. Okay, what question? Yeah, go ahead.
So can you do that with the other ones technically?
The other ones? Yeah, you can.
Negative 2x plus 1.
If you wanted to, yeah, but it's a line. Lines are really easy to graph, right? So anyway, now we only want to graph this parabola, though, for x values less than or equal to 0. So on my parabola, where is x equal to 0? Where is x 0 on my parabola here, folks? At the bottommost point right here, at the vertex, right? There's an x value of 0 right here. That's x coordinate 0. And I'm going to graph less than or equal to 0. So should I graph to the left or to the right for less than or equal to? Left. Okay, so from here we're going to go to the left. Okay, and a solid point there at the y-intercept. Okay, and then erase these other points from the parabola because they're not going to count now, right? They don't count. All right, then we'll graph 2x minus 1. So minus 1, hey, that's right there. I'm going to count up 2. So up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, and I'm out of space. Okay? Now, I'm going to start this one at 0. So it does start at 0, right? There's the point. And I'm going to go up to 5. So 1, 2, 3, 4, 5. Daggone it. That's annoying. It goes off the graph. So we'll have to eyeball this a little bit here. That's really annoying. Okay. Yeah, I'm sorry about that. That shouldn't be that way, but there it is. All right, so it's going to go like this. Okay. And again, solid dot at the end because it does equal the 5 there. So solid dot at the end. Okay. The open circle of the 0 we're not too worried about because, well, it joins up with the other piece. So it kind of makes it solid anyway. Okay. The last bit here is that f of x is equal to 3 for x values greater than 5. So f of x equals 3. Remember, f of x is just like our y values here. So y values of 3. So 1, 2, 3, 4, 5, 1, 2, 3. This point right here, okay, at the x value of 5, we're going to be a y value of 3. So I'm going to put an open circle, though, because it doesn't have the equal to. And we'll just graph to the right. There's our horizontal line there. Okay, so it's going to look something like that. Okay. There's the x squared minus 1 piece for x values less than 0. 2x minus 1 between 0 and the 5. And then it's 3 for x values bigger than 5. Okay, open circle to start it, though, because it doesn't have an equal to. All right.
So it's equal to its dot.
Fill it in. Yep. Count it. Count the point. Alrighty. Questions on the graphs? All right, we got to keep rolling here then. So now, we're asked to evaluate here. I'm pretty sure we're only supposed to do like these 4 with this graph, these 4 down here with this graph, and then these 4 down here with this graph right here. So, 2 ways to evaluate piecewise functions. 2 ways. Option 1 is you can use your graph. All right, so we're evaluating f of negative 4. So I'm going to locate the x value of negative 4, negative 1, 2, 3, 4. It's not going to quite fit, is it? Doggone it. All right, let me do an easier one. 0. Okay, you can use your graph if it fits, if the point is on the graph there. So 0. At 0, right, we have a y value of 1, right? So then the answer is 1 there. Okay, I can do 2 easily as well. At 2, we have a y value of negative 1, 2, 3. So negative 3. Okay, but let's say maybe we don't trust our graphs. Maybe we don't feel really confident about our graph. You can also use the function itself. So for example, f of negative 4, okay, is negative 4 less than or equal to 2, or is negative 4 greater than 2? Negative 4? Less than or equal to, right? So we're going to use the top function here, and we'll just plug it in. So it'll be negative 2 times negative 4 plus 1, which will be negative 7. Okay? And then f of 7, well, we'll plug 7 in. Again, now 7, is 7 less than or equal to 2, or is 7 greater than 2? Greater, so we'll plug it in the bottom one. It'll be 5 times 7 minus 4, which will be 35 minus 4 is 31. Okay? And the same thing is true over here for number 4. We can do the same thing. So for this one, negative 1, that's less than or equal to 0, so I can plug it into this equation. So it'll be negative 1 squared minus 1, which is 1 minus 1, or 0. Okay? F of 1, 1 is between 0 and 5, so that's going to go in the middle one here. So it'll be 2 times 1 minus 1, which is 2 minus 1, or 1. 8 is greater than 5. What's the answer then? If 8 is greater than 5, what's our y value here going to be? 8 is greater than 5, so that's when we're going to use this function to help determine it. What is the value of our function if we're greater than 5 here? Nope, there's no x value in here to plug in. It's just 3. It's just 3. There's no x value for us to plug that 8 in for, so it's just 3 is our answer there. Okay, just 3. And then at 0, okay, 0 is this top piece right here, so 0 goes in. 0 squared minus 1, so it's just negative 1. Okay? And again,
How do you know where to put the
because it's the equal to. So it's equal to 0, right? If f is 0, it's f of 0. 0 is our x value. 0 equal to 0, right? So that goes right in there. So negative 1 is our answer. Okay? Does that answer your question, Grayson? Yes, yes? Okay. All right. Question?
Okay, so the f of negative 4, isn't that 9? Because like I put it on like in the graph and then it's like 2, it says
Oh my gosh, it is 9 because you do negative 2 times negative 4, it's 8, and then you get positive 9. My bad. Thank you. Yes, sorry. Negative 4 times negative 2 is positive 8, plus 1 gives you positive 9. Sorry about that. Yes. Okay. All right, here we go. Julia is training for a race and has a routine for her workout. Julia starts at her house and walks at a rate of blah, 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 blah. Okay? A lot of information here. Okay? We're writing the equation for this piecewise function. So let's take a look at the first piece right here. Okay? Notice all these pieces are linear, right? So we're writing linear equations here, line equations. So, For this first piece, what's the y-intercept of this first piece? 0. What's the slope of this first piece? Nope, not 1. Be careful here. Let's see. So here's my starting point. Here's a stopping point right there. I go up how much? Well, it's 2 blocks, but it's actually counting by, it's 4. So it's, the x-axis, yeah, okay, they're also counting by 2s. I see what you're saying. The y-axis, I see what you're saying. So we could do, yeah. So don't do the little squares. Well, I mean, I guess you could kind of, but they're, look at the labels here, folks, right? So like from point to point, right, we start at 0, 0. We're counting up 4 and then going right 2, right? Up 4 and then right 2. So 4 over 2, which simplifies to just 2. So you can use 4 over 2 if you want to, or you can say just 2. Okay. What's the x value where this first equation starts? 0. And what's the x value where it stops? Yep, 3. Between 2 and 4, right? So it's a 3. Okay. All right, let's do this next piece. What's the y-intercept of this piece? It's kind of hard to see, isn't it? Is it 4? Yeah? You could use maybe like a straight edge or something like that to help you out. Yeah, let's say it might be 4. Okay? Let's hold off on the y-intercept just for right now. What's the slope of this piece at least? It goes up 2, but then right how much? 3. Yeah, 2 over 3. Or maybe it's 3 over 2. My bad. Up 2, right 3. It's 3 over 2. Or no, 2 over 3. Daggone it. Sorry, Mr. Wood's getting frustrated with himself now. All right, so from this point then, how we can use the slope to actually count backwards, right? Instead of going up 2, right 3, we can also go down 2. So down 2, left 3, and there is your 4. So you're right. We did start the y-intercept to 4 there. Okay.
Which line are we looking at?
The second piece right here.
And that, okay.
Slope of 2/3. Up 2, right 3. If you go backwards, it goes down to 4. Okay.
So
What's
3 is from starting from 0. What? I got it.
so the x value where this piece starts, folks? What's the x value where this piece starts? 3 is where it starts, right? 3, halfway between there. Okay. And what's the x value where this piece stops? 6. Okay. All right. 4. 4. Yeah. Sorry, I guess you guys can't see that. Sorry. There you go. All right. The next piece, this horizontal piece. Okay, what's the slope of a horizontal line? There's no rise, right? It's 0. Yeah, it's 0x plus, and then what's the y-intercept for this line going to be? Also pretty easy to tell, right? No. If you extend the line, what's the y-intercept? It's going to be 8. Yeah, it's just going to go at 8. Okay? So, what's the x value where it starts? Where it starts at 6, and it goes to 10. Okay? And then the very last piece here.
This is not my favorite.
Yeah, I know.
This is too long.
It's a lot. But it's just writing the equation of all these different lines. You just need slopes and intercepts. That's all you need here. So what's the slope of this line?
2.
It's up 2, right 2. So it really simplifies to 1. It really simplifies to just 1 there. If you want to put 2 over 2, that's fine, but you can also just put a 1 if you want as well. Okay? And then let's count backwards to find the y-intercept. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Down 1, right 1 would be at -1 there. That's, again, kind of frustrating if they did that. But oh well. And then we go from 10 to 16 there. It'd be -2? Did I miscount?
Actually, you go to 15. Actually, you go only to 15.
Well, so do the x's. They're counted by 2's as well.
But I said if you go only to 15, not 16.
Oh, you're right, 15, not 16. You're right, thank you. You got, wait a minute. If we start here, right, if I start here, I'm at 8, and I go up 2, I'm at 10 now, right? I go up 1 block, I go 10. But then I'm also at a x value of 10, and I go over 1, I'm at 12. So they both count up 2 and right 2 there. So that's like the same thing as counting by 1s. Right, 2 over 2 is the same thing as 1 over 1. So again, we can go down 1, left 1, 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 and we're there. Oh, I see what you're saying. It should be -2 is where it starts. Nah, okay, duh. Mr. Wid.
It's Monday.
Yeah. Yeah, that's my...
Monday sucks.
boy, this is going poorly. All right. So anyway, general idea here, folks. You have to identify the slope and the y-intercept, and sometimes you got to use your slope to count back use the slope to count backwards to get the y-intercept. Okay, and then also don't forget to put your x values where it starts and stops. X value where it starts and stops, and start, stop, start, and stop. Okay, that's all there is to it. I mean, I know I made it look a lot harder than it was, but that's because I'm trying to run through this so we can get through everything here. All right. Number 6, the graph of f of x equals the square root of x, and its image, g of x, are shown below. So here's f of x right here. It's just this piece. G of x is this bottom piece. Okay, what kind of transformation is happening here? How does f transform to be g? What kind of, it's flipped across the x-axis. It tells us that. How do we flip something across the x-axis? What do we do? So, Sky, put a negative in front, just like that. Or you could say equals negative f of x, if you like, because it does say in terms of f of x. So this should be our answer, actually, right there. Okay. G of x is equal to negative f of x. That creates that flip over the x-axis there. Okay. So, all right. Moving on. Just a few more questions here. I think we can do this. All right. So, 7a. Okay. This is that square root of x graph, right? It's the curl. All right. What kind of transformations do we see here, though? Careful, not left. Right 3 and up 4. 1, 2, 3, 4. Put a point. Okay, that's our starting point. Okay, you can make a table if you want to, using that starting point 3, and then we want to pick. Let's think of our perfect squares here. So what?
Another question. You can also find you can also do that in your calculator.
You can do it on your calculator. Exactly right. You could type this in your calculator and use the table there. I'm trying to show you this way first, and then, we'll use the calculator for the other ones here. But my point is, so we take our normal perfect squares, right? We shift them all right 3. So it would actually be 3, and then 4, and then right 3 from 4 is 7, and then right 3 from 9 is 12, and then we're going to be, it's not going to fit anyway. Okay. So 3 gave us 4. Okay. 4, when you plug it in, 4 minus 3 is 1. Root 1 is 1, plus 4 is 5. 7 minus 3 is 4, root 4 is 2, plus 4 is 6, and then 12 minus 3, well, that's not going to fit, but I'll do it anyway. 12 minus 3 is 9, 3 is 4 is 7. Okay, so 3, 4, 4, 5, 7, 6, 1, 2, 3, 4, 5, 6, and then you just connect the dots there. And again, like Trey said, we could also type this into our graphing calculator here, right? To do a square root, right, it's second x squared, and then x minus 3, and then plus 4 on the outside. Go to your table, okay? And then you got to find, some nice points here. So there's 3, 4 is where we started, right? There's your 4, 5. Keep going until you get some more nice points. There's 7, 6, okay? And there's 12, 7, so on and so forth, right? You got those points. All right, to do a cube root. How do we do a cube root in our graphing calculators? You guys remember?
You say cube.
Cube root, yeah.
I know how to do it.
It's like math.
Math button.
Second.
Well, so actually, no, math works. We just do math, and then there's cube root right there. Okay, hit enter. All right, so there's my cube root. I'm going to put in then the x plus 1 and the minus 3 on the outside. Make sure if you have a cube root like mine that you arrow out. Okay, if your cube root looks like this with the parenthesis, okay, make sure you close the parenthesis after the plus 1 and then do the minus 3. Okay, otherwise your graph's going to be wrong. Okay. So we'll graph this. Actually, I'm just going to go to the table. Okay. So here's some nice points to graph right here. 0, negative 2. Negative 1, negative 3. Negative 2, negative 4. Okay, and I'll see if I can fit some other points on there. Nope, that doesn't fit. Try this one. 7, negative 1. 1, 2, 3, 4, 5, 6, 7, negative 1 right there. Yeah, that's the only one that fits. All the other ones that fit. So something like this. Bless you. Okay, and then we got the absolute value here. Now the absolute value, those are super easy to graph. We don't even need to use our graphing calculator for this. How is it transformed? So x minus 2 means we're going to go right 2. Okay, that's our new vertex. And what does that 3/4 tell us to do? Up 3, right 4. And I can't fit any more points that way, so I'll go up 3, left 4. Up 3, left 4. Okay, and then connect the dots. Okay, just like that. Okay. So again, use your graphing calculator if you want to. Do you guys know how to do absolute value in your graphing calculator?
Yeah,
It's math, and then you have to arrow over to num, and there it is, abs, ABS. Again, if you have mine, it's easy enough to type in. Of course, I got to put the 3/4 in front there, using parentheses. Then math, num, abs, and then I'll type in the x minus 2, just like that. Okay. If you are using the, if you have the older calculator or whatever, just make sure you close the parenthesis on the ABS command, so that way you don't, take the absolute value of everything there. But there it is, right? Ta-da! Okay. Number 8. We're getting there, folks. Table below shows the value of a function. Graph that function below. All right, so I'm just going to try and sketch the graph here real quick. Okay, so let's see here. 1, 2, 3, 4, 5, 6, 7, 8. All right, so -1, -1, 0.00, 0.11, 0.8. 1, 2, 3, 4, 5, 6, 7, 8, 2. So this is what the graph looks like. Okay, that's what we've got so far. What kind of function does that look like, you think? I think it's a cube root. This is a cube root. Okay, I think it looks like a cube root function. It's not like super obvious, but I think I could see it continue to go like this way and this way, kind of thing. If you said square root there, I mean, yeah, you might kind of have an argument, but I really feel like it's cube root. So anyway, all right. Finally, the graph below, oh, well, we don't actually have the graph, but we've got this function right here, f of the absolute value of x minus 2, right? Describe how the following changes would affect the graph, right? So if we take our function here and we have f of x plus 2, how is it going to shift the graph? Left 2. We're going to ignore here. Notice here there's a transformation already in our function, but we're not worried about that. We want to know how the graph of this, with its transformation already, how will the graph of this be adjusted by these? So that shifted things left 2. What's the x minus 2 going to do? Right 2. Okay. What's the plus 2 on the outside going to do? Up 2. How about the minus 2 on the outside? Down 2. And then finally, the 2 in front. Yeah, vertical stretch by 2. Okay. Okay, so here's what I'm going to say, right? All right. I'm going to post this to Google the Google Classroom and stuff. Okay, so please take a look at that tonight, especially if you found that Piecewise stuff kind of tricky. It'll be a good thing to take a look at. All right. So I'm going to post that tonight. I'm going to put the clock up here too, okay? So you guys can see what time it is. Please stay in your seat until it reaches 2:15. Thank you, sir. Thank you, Caleb.